So obviously, my name is Eric Burke. I lead the Android team at Square. When I started at Square, it was March of 2010. There were just two of us. It was me and Crazy Bob Lee working in St. Louis back in Bob's house. So we spent the first 9 months working in his office, and his wife was amazing. She would bring us lunch every day and treated us really well, but that was an amazing experience. We've grown our team. We're up to about 5 people, and I just moved to San Francisco actually the first of the month. I've been living in an empty house all month, and my wife and kids just moved out Friday. So it's been a busy time for me, but I'm here in San Francisco now doing Android stuff for Square, and it's awesome. So let's get started. This is our card case application. So who in this room didn't realize that Square was available on Android? 1, 2, 3, 4, 5, 6. Maybe people are being shy, but I run into a lot of people who don't realize that we have Android software. We actually have supported Android all along. We have iPhone, iPad, and Android applications. This is our card case application on Android. This is, I helped write this. This is another screen in the card case application. So when you tap in the upper left corner, it kind of flips over to the payment pad and it lets you accept payments. One of the things I really like about this screen, it's a little hack I did. So when you're doing iPhone applications, it's really easy for the programmers and the designers because they know exactly what the screen resolution is going to be. So the designers always give you the 1x and the 2x assets, right? So you get bitmaps, you just drop them in, and it's awesome. It works perfectly. Well, not so much so on Android, right? You got a million different screen sizes. So if you look at the top, it's a little fuzzy on the projector, but there's this torn paper effect. So the way I did that is I have a custom view that draws a series of lines. And when the view is created, we create a random instance just seated with the current time. And it basically marches over a few pixels and then up and then down and over. It just zigzags, picking random X and Y deltas to jump across. So it looks like a torn sheet of paper. And what's really cool about this is when you tap clear and it rips away that sheet of paper, I pick a new random seed. So it looks like another random tear. So it looks like another sheet of paper. So that's the kind of detail I like to put in the user interface. It's better than a bitmap because it's scalable to any screen size. It looks crisp and clean no matter what device we're on. Unless we're on a projector, then it looks a little fuzzy and you can't even tell there's torn paper. But if you get the application and look really carefully, you'll see that tear effect. But the random seed is kind of a nice touch because it's different every time. Another screen. And another screen, and let's actually look at some source code. So we're going to start pretty simple with a custom view. So has anybody written a custom view from scratch on Android? A handful of people. Depends on what you mean by scratch.
Depends on what I mean by scratch. I've done custom views, but not from scratch.
Right, okay, so he's done custom views, but not from scratch. Like, you might extend button and add a few attributes, or extend view group or frame layout. So here I'm extending view, which doesn't give you much of anything. So all I want to do first is to keep this view perfectly square, no matter what screen I drop it on. So this is called an editable photo, and we'll see why it's called editable photo in a little bit. But to make it square, I override on measure, and then there are a series of methods you can call that are built into the view class. So all I'm doing is calling existing methods from view. So I'm calling get default size, get suggested minimum width, and then taking that width measure spec. So the width and height measure spec are passed in from Android, and those are integers that have the width and also like a constant saying like at most or exactly, and then you break it up using this measure spec class. Anyway, it's kind of tedious, kind of weird code, but ultimately I'm getting the measured width and height. And then I take the minimum of those and then call set measured dimension. Okay, so this is the first tiny step to making a custom view. I'm overriding on measure, and I'm making sure that the thing is completely square all the time. So here's what it looks like when I draw an image. So the bitmap is square. Not terribly interesting yet. One thing I do want to show that we've got different sizes here, so we can make the bearded man any size we want, and it's always going to be square. And then at the bottom we have a placeholder. So the top two images are a bitmap that we've set through code. We call set image and give it a bitmap. The bottom one is a drawable that's embedded in our Android APK file. Okay, so when a bitmap hasn't been set, it uses that placeholder photo. When I zoom in a little bit though, I want those corners to be rounded. I don't want perfectly square corners. So we want to soften it up a little bit. So you may notice from the slide, don't do this, and the red wrong way sign that this is not the way to do it. This looks really simple though, right? We create a path and we can use that as a clip. So from the path, we add a round rectangle. You can actually add any shape you want. You could make a shape where you're curving around and making like a picture of the Android robot or whatever. And then you just say canvas, clip path, and then from then on, anything you draw to the canvas is going to be clipped to that path. So it won't exceed the bounds of the round rectangle. And then we restore the canvas back to its original state. So anytime you clip the path, you want to restore so that subsequent calls to the canvas are not affected by the clip path that you just set. So this seems really easy, and it would make the corners rounded, but you get these ugly, jagged corners. Yeah, you can see that even on this projector. You can see there's stair-stepping and little pixels on the corner. The problem with this approach is that no matter what you do, Android doesn't do anti-aliasing when you use clip path. It's just a fundamental platform limitation. So even if you set a paint or set flags and say paint.anti-alias flag and then you clip the path, it doesn't work. Okay, so you have to have a completely different approach to round the corners in Android or to apply any other shape to a bitmap. All right? So lazy bitmap. Why do I say lazy bitmap? What I'm doing here is I'm going to create a brand new bitmap that is a copy of the original. So the original, I either have the image which you set in code through set image, and that's a picture of the bearded man, right? Or I have a placeholder, which is the default silhouette that you saw on the bottom picture on a few pages back when we had the 3 pictures. And then we have this third bitmap, the framed photo. So the framed photo is the one that I'm going to generate in code. It's an off-screen bitmap that I have to create to have those rounded corners. So I don't want to create that right away because in the onCreate method of a view, you don't know the width and height. So we have to wait until later when the view is actually drawn to compute the bounds. So in the onDraw method, if both the placeholder and the image are null, we're just going to ignore it and return because there's nothing to draw. So that's kind of an uninteresting edge case, but we need to do that to avoid null pointer exceptions. So next step, if the frame photo is null, then we need to lazily create it. Now onDraw could be called over and over and over again if you're animating a view. So you don't want to create a new bitmap every frame of that animation, right? You'd very quickly, well, you'd make your app really slow and potentially run out of bitmap memory. So you want to create the bitmap once lazily when it's first requested, and then after that you reuse the same instance over and over and over again until the view resizes. Okay? So I call a method create frame photo, and I pass in the minimum of the width and height. Technically that's not necessary to call math.min because I also ensure that the view is already square, so I could just take the width or the height. I guess the code just looked a little more clear to me doing it like this. And then I call canvas draw bitmap with the frame photo at the upper left-hand corner 0, 0, and then I pass a null paint object. So creating that frame photo, that's creating the off-screen bitmap that has the rounded corners. That's where the magic happens. We have to use a technique called alpha compositing. So if you go to Google and you search for alpha compositing, odds are the first hit or two is going to take you to this great Wikipedia article. And this Wikipedia article has this image on it. So all we're trying to do here, now I don't really get into all the math of this. You don't have to because Android gives you APIs to work on this without getting all mathy and technical. But the general idea is you start with a transparent canvas and you draw one image, and then you set this transfer mode, and then you draw another image on top of the original image. And then depending on the intersection of the pixels in those two images, you'll get a third resulting image that is the composition of the two. So this diagram attempts to show you the different modes, like A over B, A in B, A out, etc. Okay, so it's almost like you're taking two sets and you're trying to get the intersection or the union of the sets or whatever. Okay, so there's different modes to tinker with, and that's how we're going to add the round corners to the bitmap. So the create frame photo method takes a size, that's the width and height, because we're making a square image. First, I create a drawable. So remember, I have either the bitmap image that you set in code, which is the bearded man, or we have the placeholder drawable, which comes from a drawable that's embedded in your app. So we've got either a bitmap or a drawable, two different incompatible classes. So what we need to do is take the bitmap and wrap it with a bitmap drawable. That's what this first line of code is doing. It's kind of like housekeeping code. Once we've got this, now we have a drawable, regardless of where it came from, and we can work with it in a consistent way. So then we create the off-screen bitmap. So you say bitmap, create bitmap, you give it a width, you give it a height, and then you give it a bitmap config. So the config I pretty much always use is ARGB 888. Okay, all that does is create a bitmap that has an alpha channel, so it supports transparencies. Then another little bit of housekeeping, I have to create a rectangle that matches the size of the bitmap. And then I compute the outer radius. So the corner radius, in this case, I take the size of the bitmap and divide it by 18. Okay, does anybody know what's magical about the number 18 when you're dealing with graphics like this? Any guesses? Something related to a 9 patch? Okay, 9 times 2 is 18. Okay, that's a good guess.
Absolutely nothing.
Absolutely nothing. Right. Half of 36. No, still, absolutely nothing is still the right answer. What this was based on the width of the image, I need to pick a corner radius. As the image gets bigger, I want the corner radius to be bigger because bigger images have bigger corners. And as you shrink it down, I want proportionally smaller corner radiuses. Radii, whatever. So this was me typing in a number, compile, deploy, look at it. Nope, that doesn't look good. Let's try a different number, compile, deploy. It just so happens 18 happened to look good to me. Okay, so the point is here, I'm kind of teasing you guys a little bit, but there's nothing special about 18 other than I thought it looked good. But the point is I don't use device-independent pixels. I don't use pixels. Instead, I pick a ratio of the width and or height, and then base the radius based on the size of the view. The reason I do it like this is because this is going to scale to any Android device. It's going to work on the Galaxy Tab, the Dell Streak, a Hero, without me having to get in there and tweak pixels on every single phone. Okay, so you're never going to completely get away from pushing pixels on a UI, but whenever possible, you want to deal with ratios and percentages of overall sizes. That way your UI is going to be flexible to far more devices with far less work on your part. Okay, so that's where that 18 comes from, is trial and error. So create a paint object. At this point, we can specify anti-aliasing. And what anti-aliasing does is gives us nice, smooth corners. And I set the color, and then I call canvas, draw round rect, give it the rectangle, the radius, and the paint. And then I have this beautiful, opaque, red, round rectangle with nice, smooth, round corners. Okay, and if I stretch that to any size, the corners are going to stretch along with the image. So it's a little strange to draw an opaque red rectangle, but remember we're going to use this alpha compositing. So the technique is to draw the rectangle first on a transparent off-screen canvas. Then we draw the bearded man, the drawable, on top of that. And then because we're using Porter Duff mode source in, any pixel that intersects will be kept, and any pixel that falls in those transparent corners is going to be dropped. So we're going to be left with this beautiful rounded image with the rounded corners. So in the previous slide, I drew the round rectangle with red. It doesn't have to be red. It can be any color. It just has to be an opaque color. I like to use red because when I'm testing, it's this vibrant in-your-face color, and I can tell immediately what's going on. If I had made it like black, then I load it on an Android device, the default background is black, I wouldn't be able to see what's happening. So I just make it an obnoxious primary color whenever I'm testing things. So we set the Porter Duff mode. We set the bounds of the drawable. This is important if you, remember we're dealing with drawables instead of a bitmap. So whenever you paint a drawable in Android, you have to explicitly set the boundaries of the drawable. Otherwise it defaults to 0 by 0, and then when you draw it, you get nothing. And then you're banging your head against your keyboard wondering, why isn't it drawing? So you have to set the size. And then I save the layer temporarily because, again, because I'm drawing a drawable, I can't apply a paint directly. I have to assign the paint to the canvas. So this is a little trick. You save the layer, you give the paint as a second argument. I'm kind of gesturing towards my screen. I don't know if that's all that helpful to you guys. Maybe I should point to the slide there. I draw the bearded man on top of the round red square, rectangle, whatever, and then I restore the canvas to its original state. And then we're left with a nice image that has nice, smooth, rounded corners with anti-aliasing, so we get nice round corners. Okay, so we're getting a little closer to the editable photo that we want. What we want to do now is add a photo or a frame to the photo. So I'm not going to show you every line of code like we did in the previous step because it's essentially the exact same procedure. So first we create an off-screen bitmap, and we create a canvas that matches the size of the bitmap. Then we draw an opaque round rectangle in the middle. So we're insetting it a little bit because we're going to punch this out as a whole for you to see through. And then we set the mode to source out, which is a slightly different mode because we want to remove the area that's in the red rather than keeping that area. And then I draw a larger round rectangle with partial transparency right on top of the red, and then that center section actually gets punched out and removed because of the Porter Duff mode. And I'll be completely honest, when I do stuff like this, I usually guess the wrong Porter Duff mode, and I just keep trying until I hit the right one. It just, you know, it takes a while to sink in, I guess. So we draw this round rectangle, then we have another bitmap. We've got the original bitmap, and now we have this round rectangle bitmap. We draw them on top of each other, and then I draw the text edit on the bottom, and then we have this nice custom component that we can use. That's why I call it editable photo, because when you see this, you can tap it to edit your profile picture in our applications. Okay, so that's basically the steps I followed to create this custom view in Android. Now in Android it's nice because any view you can register an on-click listener. You don't have to do anything special for that. So you just register an on-click listener, and when you tap it, it gets an on-click event, and then you can go into the photo selection or whatever. Okay? Are there any questions so far? Am I changing the state of the image on click? Like showing it like pressed or whatever. So I'm not doing that, no. If I wanted to, I suppose, you know, one thing you could do, we're doing this elsewhere actually, is we apply a partial transparency, like we set an alpha on a component, so when you press it, it kind of looks dimmed out. A trick in Android though is they didn't add the set alpha capability until something like Android 2.3. So the question is, how do you set an alpha on a view on older Android releases and maintain compatibility? Does anybody have an idea how you would do that? Yeah, overlay a view on top. You could. That's just going to kind of add a darkening or a brightening effect. Actually, the way you can set an alpha is you can create an animation that they have an alpha animation, right? So you can set an alpha animation with a duration of 0, and you can set fill after to true. So when you apply that animation, it instantly turns transparent or translucent, and because fill after is true, it sticks. So once you press, you could set the animation, and then when you release, you could clear the animation, and that would set an alpha on your component. And that actually works on any view, or you could do it on a view group that has a bunch of children. And we're actually doing that in the next version of our card case. When you tap on a card, we're applying an alpha animation to make it partially transparent so you can drag cards around and it looks really awesome. So that's just a little Android hack you can use to apply an alpha to older SDKs, even though they didn't add set alpha until Android 2.3 or so. All right, so this is Dr. Evil on an edit screen. Dr. Evil is one of my go-to characters when I'm testing. My account, I'm always either the Bearded Man or Dr. Evil or Oprah. Occasionally Gene Simmons also. So it's just a good way to know I'm hitting the test server and not production data and actually charging myself $10,000. I did come home once and my son had been playing with my phone and I noticed in the payment history there was a $1 million payment. And fortunately it was on the staging server. So that really happened. And it's still in payment history. You can scroll way through my payment history and eventually you hit a $1 million payment. Like, oh my gosh. So this screen's kind of fun. So the background right now is solid gray. So I want to jazz it up a little bit. So if you were to look at pretty much any modern UI, if you zoom way in, you're going to notice that almost every screen in OS X or Windows or whatever, they apply gradients to everything. So first thing I want to do is apply a gradient to this screen. Now, this is not the real gradient. I mean, this is way too dark and way too ugly. What we really want is a very, very subtle gradient. So you almost don't notice the gradient, but it does add texture and depth to the screen. So the reason I make it dark is, again, the same philosophy as the red rectangles. When I'm testing, I want to pick bright, dark colors so that it immediately pops out at me, yeah, you're doing the right thing. Because when you create a gradient like this, you have to choose an angle. I know now this is 270 degrees, but when I first coded it, I'm like, okay, does it need to be 0, 90, 180, or 270? So you make it nice dark colors and then it jumps out right away and you see if you're doing the right thing. So the gradient just goes into resource drawable. We create a plastic background.xml, and this is a standard Android drawable. There's nothing custom here whatsoever. Okay, so just create a shape drawable, gradient, you give it a starting color, an ending color, and an angle. I'm going to extend linear layout. I call it plastic linear layout because we want this screen to look like a sheet of plastic. So in our applications, most of our screens look like paper, but then when you go over to the settings side of the application, they look like plastic. Okay, so extending linear layout in the constructor, I call set background resource and r.drawable plastic window background. That's the XML file from the previous page. So all it does is apply a very, very subtle gradient. And you can't even tell it's there on the slide. I probably need to make it a little more, adjust the colors a little bit. I think it's a little too subtle. But to really make it look like plastic, we want to add a shiny effect. So again, I pull out the primary colors. I make it pink just so I can see what's happening. We want to draw this triangle on top of the background, but behind the children views. So it goes from the upper left corner down to 80% of the height. And there's a gradient going from top to bottom in that triangle. The way we do that is in that plastic linear layout class, I have a private method called createShinePath. And I ask the view for its width, and I ask the view for its height, and then I multiply that by 0.85. Just because through trial and error, I found that 85% of the height is a good approximation of the mock-up that the designer gave to us. Okay, so the designers are not going to give you a separate design for the Dell Streak and for the Galaxy Tab and all these other devices. They're going to give you one design and then you have to interpret it for all the different Android phones. So it makes your job really awesome. So once I have that height and width, I create a path object. And then, I don't know if you've worked with a path before, but you basically move to a starting point. So 0, 0 is in the upper left-hand corner. And then you have a series of line twos. So I draw a line from the upper left corner to the upper right, and then down, and then close the path, and it makes a triangle. Okay? In the triangle, I now need to create a linear gradient. This is a case where you need to create the gradient in code because I don't know what the height is. So I'm creating the gradient starting from the upper left-hand corner, 0, 0, going down to x equals 0 and y equals the height. So the gradient is going straight up and down, and then from the starting color to the ending color, and then you give it this last parameter called clamp, which means the gradient stops when it gets to the bottom. Okay, so you need to set this in code because you need to know the dimensions of this gradient. So once it's finished, the shine path is you can't even see it on the projector. I can see it on my screen. It's really there. You can see it on a phone too. It's just this kind of path that goes here, and it makes it look like shiny plastic. Okay. I had this idea. I haven't done this yet, but what I really want to do is hook this into the accelerometer so that when you rotate the phone, the angle's changing. I can just adjust the brightness of the colors so it looks like a shimmer, like a reflection. I think that would be really awesome. And I'm either going to do it or I'm going to make Demetris do it. Where are you, Demetris? He's another programmer on my team. He's in here somewhere. He's cringing right now. No, not more work. Okay. So PlasticLinearLayout. This is the class. So we've got a private paint object that has anti-aliasing set. So I'm drawing a triangle, but I'm still using anti-aliasing. The reason I'm using anti-aliasing is because the triangle goes diagonally down the screen. And if you didn't use anti-aliasing, you would see little stair-step pixels going across the screen. So use anti-aliasing to smooth it out. One of the few times that you don't use anti-aliasing is if you're drawing like a straight line or a rectangle. Then you can get away with avoiding it. But usually if you have angles or curves, you want to anti-alias just about everything in your drawables. So in the constructor, I set the background resource. We already saw this code. All we're doing is extending the example to override dispatch draw. Dispatch draw is in the base class. We're overriding it here. This is called immediately before the children are drawn. So this is your hook. It's your opportunity to draw custom stuff either before or after you draw the children. Or you can actually not call super. You can just take over drawing yourself and do some really interesting, kind of amazing things to the children, which I'll show you in a few minutes. So we're overriding dispatch draw because I want to draw the shine path behind the children. So this is another example where I'm lazily initializing things. So I can't create that path in the constructor, and I can't create that path in onCreate because I don't know the width and height of the view yet. Once onDraw or dispatch draw is called, though, I know that the view has been assigned dimensions. So I can go ahead and create the shine path at this point. Only do it once, though, and hold on to it after that to avoid creating the gradient object over and over again. And then I draw the path, and then I call super dispatch draw. If I wanted to reverse this order, I would simply move dispatch draw up a few lines, and then the path would be drawn on top of the children instead of behind the children. Okay, so this gives you a lot of fine-grained control over when you draw things relative to your children. This would be useful for, you know, like if you're like beta testing an app, you could like draw like the word beta on top of an app or whatever. You could do some kind of creative things with dispatch draw, I think, and some transparency. So whenever layout occurs, this means that the bounds of the component have changed. So what I like to do is anything that needs to change based on the dimensions, I just reset it back to null. So here I just say shine path equals null. And then the next time onDraw is called, it'll be lazily created once again because I check for null and I create the shine path every time onDraw or dispatch draw is called. And then this create shine path is what we saw just a minute ago. Okay? Are there any questions about this? All right. I've done an amazing job explaining because there are no questions, obviously. Uh-oh. Crap. Yeah. Okay, so the question is, he saw a demo where they're doing like a WYSIWYG kind of layout editor where you could see this stuff on screen. So here's the deal. we don't use any of those tools at Square. The reason is we have a very complicated application, and the Eclipse tooling and all that no longer works. So some of the issues we face is we have two applications. We have CardCase and we have Square. Okay, there's a ton of code that's shared across both applications. So all that code goes into a project we call Core. The other thing we have is we have beta versions of our applications. So we have CardCase Beta and CardCase Production, Square Beta and Square Production. So on an Android device, you cannot have two applications installed on your device at the same time with the same package name. So they have to have unique package names. So for us to compile our application, the other piece of this is there's a bug in Android that they haven't fixed. There's no way to create a library project that has custom components that have custom XML attributes, because when you add custom attributes to a view, you have to have those in a package name that matches your app. And then when you basically can't bundle that core library project in a jar file and just reuse it. You have to actually take those XML files, copy them to your project, rename the XML, and then we also have to rename the XML for our beta versus production apps so that they can coexist on the device at the same time. So you can imagine for a non-trivial project, our build is very complicated, and unfortunately it's so custom that none of those tools work. So I can't really answer your question. The good news is in R15 of the development tools, they are allegedly going to fix this issue with library projects and custom attributes so that you'll be able to develop custom components and put them into a jar file and just share that jar file into your applications. So once that happens, hopefully we'll be able to use more of the standard tooling and get that kind of real-time layout and all that. But right now we just hand code of all of our XML. You had a question? Yeah. So the question is, are compositing and anti-aliasing hardware accelerated? They are if you're on Honeycomb or Ice Cream Sandwich and you've enabled hardware acceleration. So we haven't got there yet with our apps. We go all the way back to API level 7. So we're really looking forward to Ice Cream Sandwich. But even so, we're going to have conditional logic in our app at some point, or we're going to have another special build. So, okay. So takeaways. Use gradients all over the place. It makes your UI look great. When you're testing, use bright primary colors, and only invalidate your drawables when the boundaries change. You don't want to reallocate bitmaps and gradients and all that on draw, because those are called over and over and over again. You're going to use a ton of memory and you're going to make things really slow. So tools that I use constantly are digital color meter, because you can just zoom in and pick out colors. In Lion, though, they took away the hex, so kind of made it useless. So you can go buy a tool called Xscope, which unfortunately is $29, but it does essentially the same thing as digital color meter. So if you want to add custom attributes to components like that, you put those in res values adders.xml. In that XML file, you would declare a stylable, give it a name like editable photo. In this case, the editable photo matches my Java class name. And you list the attributes. So these are name value pairs. The value is the format, and you have string, dimension, reference. I guess the way I learned how to do this is just to grab the source of Android and study adders.xml for all the stock components and kind of just learn how they do things. There are a few gotchas, like once you define a caption, format equals string, like if you have another custom component later in the file that also uses a caption attribute, you have to omit the format. If you list format equals string twice, then it blows up. It doesn't like that. So it's almost like these go into a kind of like a global namespace or whatever, and they collide with each other. So it's just a little gotcha. To reference the component in your XML file, you have to give it a namespace like XML namespace square, and then you use this schemas.android.com, and then the last part, com.squareup, matches your application package. So this is where when we build the production versus the beta version of our app, we have to copy the XML files and replace these namespaces with com square up development or com square up beta so that we can have two versions of the app coexisting on the device at the same time. It's loads of fun. And then to reference these, whenever you have a custom view, it's a Java class, and odds are it lives in a package. So your XML tag just becomes the class with the package. So com square up editable photo is the tag name. And then the custom attributes are using your namespace, like square, colon, caption, caption size, placeholder, and then these are just, they look like normal Android attributes except they're prefixed with your application namespace. Okay? The really nasty code that I'm not going to get into too much detail on is in the constructor of editable photo, the way you get to those custom attributes is you obtain styled attributes from the context that gives you this typed array class, and then you have to grab like all these attributes from the typed array by calling methods like getDrawable, getString, getDimension. All these lines in bold are generated as part of your generated R file. So you know in Android whenever you have XML like colors and layouts, they generate r.java, and that has r.layout.whatever, r.color. It also has these custom attributes r.stylable for anytime you have a custom XML attribute, it goes into that r.java. So that's where these all come from. Again, this code gets kind of nasty, so I think the best way to learn it is to study the source of Android and check out how they do it in the stock components. All right. Small things are really hard to touch. Okay? What this means is if you have a really small UI component and the user picks up your phone and they're like, why isn't this thing working? It makes your app feel broken. It requires far too much precision to touch that tiny target. What you don't necessarily want to do though is make big goofy Duplo, you know what Duplo blocks are, I can't say it. You know, they're like the giant kitty version of Legos. They look terrible. You don't want big Duplo UI components. So instead what you do is you make an invisible component behind the smaller component, and you create something called a touch delegate. So that way it looks small and awesome, but when the user touches it, there's this slop factor. They can touch anywhere in the nearby region. It hits that touch delegate, and it makes your UI feel more responsive. The thing that's kind of nasty about touch delegates, though, is the API is a little awkward. So when you create the touch delegate, you have to know the width and height of the parent view. So normally when you're setting up your layout, you do it in the onCreate method, right? Well, the problem is onCreate, you don't know the dimensions of your components. So the typical workaround for this is to call, like myButton.post. You put something on the event queue, and then post gets processed after layout occurs, and then the dimensions are known. So it's kind of kludgy. So all we did is we have this helper class called views, and we have a static method called expand touch area. And it takes two arguments. It takes the big view and the small view. That's another thing. When I was working with a touch delegate directly, it was always confusing to me which of the two is the delegate. Is it the small one or the big one or whatever? So I just made this static method, and I called them big view, little view. It makes it really obvious when you call it. So all I do is say big view.post, new runnable, and then big view set touch delegate, new touch delegate, and the touch delegate is built into the Android APIs, right? And you notice the first argument is a rectangle, so that's the bounds of the larger component. And then the second argument is the small component. So that expands the touch area, makes things easier to touch. This is actually based on a well-documented theory called Fitz's law. Again, if you search for Fitz's law, you're going to be taken almost directly to a Wikipedia article that lays it all out in great detail. Again, it has a bunch of math behind it. It's very well documented. It's basically talking about a speed and accuracy trade-off. So the takeaway is make targets big and close. So Fitz's law says that in a user interface, if something is far away, this is usually not a problem on mobile so much, but if you have a mouse and a pointer and you have to move your mouse all the way across the other end of the screen, it makes you slower, right? Also, if targets are really tiny, it also makes you slow because now you have to be very precise when you tap on it or when you click on it. So if you make things bigger, you can go really fast. If you're on a Mac, you have something up against the top of the screen, you can just fling your mouse up and it just anchors at the top and you can tap and there's this sloppiness to it and it makes you super fast. So this is called Fitz's Law, and in the context of mobile, I guess in general it just means use touch delegate whenever possible to make your touch areas larger, okay? So, another screen in our application. We've got a map view. This doesn't show it here, but when you first come up to this screen, the map actually animates and moves around and then zeroes in on your location. So we wanted to make the corners round like we did before with the photo of the bearded man. But we didn't want to do it with off-screen bitmaps because that map is animating. And if we had made an off-screen bitmap for every frame of animation, that would have kind of been really slow. So instead, I extended frame layout, call it round corner viewport, and in the dispatch draw method again of this frame layout, you can wrap this around any child now because it's a normal frame layout. I save the layer, and then I call canvas.clipPath. This is exactly what I told you not to do a little while ago, right? I said don't use clip path because you get jagged corners. This is not an exception. I call super dispatch draw. So this draws the map view that's contained with round corners, and then I restore it to the original state. But you definitely get jagged pixelated corners. You can barely see it there. It's definitely there though. The way we fix that is we draw a round rectangle on top of the jagged corners, and we use a borderline paint, which has like a 6-pixel width stroke. So it's kind of a hack. All we're doing is we're drawing the round rectangle, and then we're drawing on top of it to cover up the nasty jagged pixels. But the end result is it looks amazing, and nobody knows what's behind the curtain, but me and you, but we'll keep it a secret. I don't know if there's any profound lesson to be learned here, but basically, you know, sometimes you just resort to stage magic, I guess, to you know, whatever it takes to make the UI work. Input method options. Kind of jumping around here, but this is really important. I notice, you know, people get this wrong a lot in Android. It's a tiny, easy thing you can do. Anytime you have an edit text in your UI, you should always set IME options. So there's a variety of them like action done, action next. What that'll do is it'll control the text on that button on your keyboard in the lower right-hand corner. And it just makes your UI a little faster and easier to work with. Not every phone honors this though. I don't know if they fixed this or not, but I think HTC Sense ignores this for action done, so it doesn't turn it into done. They may have fixed that in newer releases, I'm just not sure, but that's why we have the done button in the upper right corner, because we can't guarantee that it's going to be on the keyboard. The best you can do is set the IME options as kind of a hint to the platform to hopefully make it into a done button. Another thing you can do is when the user taps that done button, all it does is dismiss the keyboard. But what I wanted to do on this screen is when you tap done, I want it to actually click that, do the same thing that tapping that button does, so it actually dismisses the whole screen. So all you do is you add an editor, on-editor action listener to your text view. And then if the action ID is IME action done, then you can call your done clicked method. So that's all you have to do to tie into the done button on the keyboard, is add that listener. So some other things you should definitely look into is using action next. So whenever you have a series of fields that people have to edit, they can just tap the next button and it moves focus to the next field in your UI. Input type is important also. When you set the input type to phone or person name or cap words, that controls what kind of keyboard appears. So in the case of a phone number, you get the phone keyboard. And when you set the input type to text person name, text cap words. As you're typing, it capitalizes the first letter of each word. And there's another option where you can capitalize every character. So we use that when we're editing the state. So you type CA, both are capitalized automatically. So it just speeds people up a little bit. Is anyone in the room thinking of using View Flipper? Yes, you are thinking of using View Flipper. Awesome. I love View Flipper. View Flipper is a great component. If you're not familiar with it, what it is basically is it lets you show one child at a time. So it's not actually flipping like a 3D flip or anything like that. Instead, what it's doing is more like a card layout in Swing where you show one card at a time. But what's great about View Flipper is it lets you animate between views really easily. So we use that all over the place in Square when we want to slide a panel to the right or left, or when we want to crossfade between views. We use View Flipper for that sort of thing. However, View Flipper has a nasty bug, 6191. So anything prior to Honeycomb, it would occasionally crash your application. We ran into this because our original version of Square way back in 2010, we started seeing exceptions on the market from View Flipper. And what it was, when people would change the orientation of the phone between landscape and portrait, the View Flipper would just occasionally throw an exception. It's not the kind of thing you're going to notice during development because it's very rare, but as you start getting 500 users, and then 1,000, and then 20,000, and then 300,000 users, you'll see this exception all the time. So the fix is override, basically extend View Flipper. So I wrote a class called SafeView Flipper, and it's on, we've got the URL there, but the slides are going to be available on the user group's website, and also if you just Google SafeView Flipper, you'll find this. All I do is override the method onDetached from window. I call super onDetached and just wrap it in a try-catch block. So when the super class occasionally just randomly throws the illegal argument exception, I catch it, call stop flipping, and then I ignore the error. Now normally you don't want to ignore errors, but this is a platform bug and there's really nothing you can do, so you just ignore it, and then that way your application doesn't crash. You're going to miss, I'm not exactly sure what happens when you call stop flipping abruptly like this. I suspect just the animation is going to abruptly stop, but it's better than crashing your app. Okay, so use SafeView Flipper and set those animations on it and make sure your UI look great. I love the component, but it just has this kind of nasty glitch that you need to know about. This is our card case app. What I'd like to do is kind of describe how we implemented this. Now, I kind of faked this out a little bit for Keynote. That card in the middle, the font doesn't match exactly. That's because I tried to get Keynote to show what happens when you tap a card. What happens when you tap a card, it slides up out of the pocket, and then it slides down to the middle of the screen. And the back of the screen grays out, but I didn't get that working in Keynote. So basically, you just imagine that's happening. You tap, it comes out, slides down. So that was a trick, is how do you get a card to slide into a pocket in a UI, and then once it's at the top, it comes down. Now it's on top of everything else. Okay, so the way we did that was, first I override a method called getChildDrawingOrder. Okay, now the whole thing is just a custom view that extends viewGroup. And then I just override a series of methods. So getChildDrawingOrder, all it does is normally when a view group has a list of children, Android just draws them in order from 0, 1, 2, 3, 4, and whatever. getChildDrawingOrder lets you return an array where the indices are all shuffled around. So when a card is, when they're in the pocket, they're drawn in order. But when it slides up and then down, we alter the drawing order so that card is drawn on top of everything else. That's the first, call it technique. I don't want to call it a hack, but it's a technique that we use to implement this screen. Second thing is we override the drawChild method. Almost everything else in this screen is done in the drawChild method. So Canvas clip rect is a key example. Each one of these cards is a child view that has its own layout and buttons and all that. So when the overall panel draws the children, right when draw child is called, we override that. We call canvas clip rect to set a clip boundaries, or a boundary that goes right along the pocket here. So the clip rect is like basically up here. So anything drawn outside of this rectangle will not be drawn. So then we just call super.drawChild. It draws this card, and then we call canvas.restore, and then that's how we get the cards to slide into the pocket. Now when we're animating the card, we really don't have to do anything special. We just set an animation and tell it to go, and then Android automatically keeps redrawing things, and each time drawChild is called, we just set the clip rect, and regardless of where the card is, it's clipped right along that pocket boundary. We don't have to worry about the jagged pixels and the corners and all that here because we're clipping a rectangle and it's a straight line. Okay, so in a lot of respects we kind of got lucky that the design happened to be supported by some key APIs in Android. And then the last thing we do is combination of canvas translate and canvas rotate. If you notice on this last pocket, this has 4 cards in it, so the first card is drawn straight, the next one is translated up a little bit, the next one is translated but also rotated a little bit, and then the next one is rotated the other direction. So it looks like they're kind of shuffled and kind of jammed in that last pocket. We call this the overflow pocket. So again, in the drawChild method, we override that. We call canvas translate, canvas rotate, then we call super.drawChild, and then we call canvas restore, which undoes the translation and rotation. And it makes the cards look like they're shuffled and kind of jammed in that last pocket. Okay, so that's how we implemented this screen. So my parting advice for Android developers in general is, first of all, do not crash. I haven't really covered any special techniques. So the most important technique for do not crash is when you're testing your Android app, hold it sideways and then rotate it. And then rotate it again, and then rotate it again. So maybe make like one of the things we ought to do is make like a Lego robot that just rotates the phone all day long. That's got to be the #1 cause of exceptions in Android apps. So test that, don't crash. The other thing I think is just details matter. I think just in general, one thing that's been unique for me working at Square as opposed to my previous life where I was in corporate America for many years. This is the first time I've worked at a company that's actually driven by design. And it's not like, yeah, we hired a designer and he tells us what his great ideas are and then we programmers just ignore it. No, the designers run the company. So every time we implement a feature, we have to go to a design review. And they sit there and they look at it and they nitpick it and they throw it back at you. And then when we're done with the design review, before we release, we have a Jack review where we go sit down with Jack Dorsey and he does the exact same thing. And that's really awesome, but what it's taught me is that details matter a lot. And I always thought I was good at UI design and then I just realized, no, I sucked. I wasn't doing nearly enough. You need to use that digital color meter tool, because it lets you zoom in and look at every little pixel. Just obsess over making sure that things align. If they're off by 1 pixel, you won't necessarily consciously notice it, but it makes your UI feel sloppy and kind of broken and chintzy. So just obsess over details like that, and use little subtle animations, leave plenty of white space, things like that. And above all, I think a lesson is to really do as few features as possible, but to do those few features really well. That is almost always better than a long feature list of poorly implemented functionality. Okay, so no matter what, your users are going to complain. They're going to say, well, you don't support feature X. Well, the worst thing you could do is just throw in feature X just to shut that person up, because then it's going to be a poorly implemented feature X because you're so busy throwing in features that you don't have time to make it really amazing. So anyway, that's just some random advice, take it or leave it. We definitely have time for some questions. So the question is, how do we deal with multiple display sizes okay, so I've already mentioned our apps are just complicated enough where we can't just use the visual layout tools, right? So, like one of the things on the round corner and the triangle, I try to do things in terms of percentages of the size when possible. One thing I look for when I'm doing code reviews is if I see that people are using, we definitely use DPs, like device independent pixels, all over the place, right? But usually I use hard-coded dimensions as padding between components. If I'm doing a code review and I see that you've created like the width of the entire button as like 300 pixels or 180 device independent pixels, that's a red flag for me that you're probably doing layout wrong. Usually you don't want to use dimensions for large regions of space in your UI. Instead, you want to use it for gaps between things. Instead, you want to really become a master of linear layout, relative layout, and potentially even writing your own custom layouts from scratch. I think the key, there's no magic formula for this other than you really have to learn the layout managers well. The thing that served me really well also is almost every UI, you can break it down into one area that's stretchy and everything else is fixed. Like you have a title bar at the top that's fixed, and then you have a list view that fills the remaining space. So kind of the go-to technique for that is to use a linear layout that's vertical. You set the title bar to be like wrapped content, and then the rest you set the height to be equal 0 dp, which is a little counterintuitive, right? You set it to be 0, but then you give it a layout weight of 1, so it takes 100% of the remaining space and it just stretches. Or you could do that with a relative layout where you attach it to the top and you attach it to the bottom. Give it a height of 0 pixels or whatever, but then it just becomes stretchy because of those attachments. So there's no like silver bullet answer to how you get it scalable to any screen size, but picking a stretchy area really helps, and just watching for cases where you're using dimensions for big regions instead of just for little gaps and padding, I think it's kind of a red flag that you might not be using layout managers right. So hopefully that helps a little bit. So any other questions? So the question is, have we built a tablet version of our app? And if so, did we use fragments? No, we have not built a tablet version of Square on Android. Some of that gets into talking about what our company plans are and all that. I think I think the Android team wants to get into the tablet space. To be honest, there's a couple things holding us back so far. One is just resources. We haven't hired enough people. We're just really busy. The other thing is there hasn't been a compelling Android tablet that has a big enough market share, a low enough price point, to really justify that for us. That equation is going to be different for everybody. So I suspect somewhere down the line we'll get in that space, but we just haven't done it yet. And no, we're not using a lot of fragments. We are starting to move towards dialog fragment. We are using the compatibility library. There's some good stuff in there. Not regular fragments yet. Honestly, so far I've been able to use SafeView Flipper for a lot of the stuff that fragments can do, and it seems sufficient. Yeah, I'm glad someone noticed that. Where did we get the Helvetica font from? So we did license that font. I don't know where we got it from because I wasn't. It was a guy named Randy Reddig. He licensed it. Yeah, so the way we got Helvetica is we licensed the font, you put the font into, what's the directory? Assets or whatever. And unfortunately, you have to write a custom view inflator. So all of our activities extend from a common base class called Square Activity. And in the base class activity, you can create a custom view inflator. And we intercept all view inflation, and if it's a text component, we check for that, and then we set the font on it. And it was a huge amount of work, and we still find cases where we've messed it up, and it's just very time consuming, and it's kind of an amazing hack. One of our guys, Patrick, did that during Hack Week. He got Helvetica working on Android. You know, with Ice Cream Sandwich coming out with the new Roboto font, I'm debating, you know, I haven't talked to our designers about this, but my thought is we might just go to Roboto because we'll just get it with Ice Cream Sandwich, but then for all the older phones, we'll be able to match. Our general direction is to try to evolve towards more of an Ice Cream Sandwich look and feel on all Android levels. We haven't got there yet, but yeah. How many devices do we test against? A lot. A lot of that is because we do, you know, we have the reader and we do audio processing. So the way the Square reader works is it's essentially a mag stripe reader and a resistor, and it's basically treated like a microphone. So the audio turns out to be very different on Motorola versus HTC versus Samsung. So we have to actually sit there and plug this in and take hundreds of test swipes on every phone and do a lot of regression testing on that. So yeah, we've probably got at least 30 to 40 Android devices that we test on. Yeah. Yeah, so questions about assets. Do we use bitmaps or do we use vectors? So whenever possible, we use vector graphics on Android. Our app hovers around 3 megabytes right now. And at one point, it was over 4 megabytes. And you get people complaining about it. They're like, why don't you support move to SD card? Well, the reason we don't is because when you take a payment, we use background queues. And when you move to an SD card, if the user plugs in that wire and mounts the drive, all your background services are instantly killed. And then when you unmount or whatever, you're not restarted automatically until you run the app. So what would happen is people would lose payments. So as a payment processing company, we can't do that. So basically, okay, I'm getting way off topic there, but basically the answer is we have to make our app as small as possible. So you really want to, whenever possible, avoid large bitmaps and do as much vector graphics as possible. All right, thanks for having me.